This conference will now be recorded.
Hi everyone, good morning. So we'll wait for 2 more minutes for others to join and then we'll start our discussion. We'll give a couple of minutes for other learners to join and then we'll start our discussion. Once again, welcome everyone. Good morning. So in our yesterday session, we discussed about what are the course content that we are going to discuss. Okay. So pretty much today we are going to start the day one. Today we are going to discuss the first topic uh, of our course content. Just a minute, I'll show you. So introduction to performance engineering. Okay, introduction to performance engineering. Okay, so performance engineering. If I discuss about performance engineering, first of all we should get a basic understanding of performance engineering because uh, that understanding is basically missing. Okay, performance testing, what we are doing. Okay, mostly you guys are doing, right? Performance testing. Testing means what? You are going to test a particular application and you are going to say response time is this much, hit per second is this much, throughput is this much, throughput is this much, your CPU is this much, memory is this much, like that. You are providing the numbers. You are providing the numbers. Okay, you are providing the numbers. Just a minute, guys. Yeah, sorry. So one of the learner from US, he wanted to join, so that's the reason he called. Okay, no problem. So testing, obviously, you are going to test a particular application, and you are going to say like, this is the number. Okay, so giving or getting that metric, that is, you are completing your testing activity. Okay, but performance engineering is actually the next level. Okay, performance engineering actually the next level, because say like you are getting so and so response time. Example, you are getting 10 seconds, or your CPU is actually 80% or 90%, your memory utilization is actually 90%, like that. So that number, you are going to get the detailed information. Engineering means what? You are understanding, identifying, debugging, investigating to find the problem. Okay, so engineering is something you are doing to find the bottleneck, to find the bottleneck. Okay, you are saying that particular 10 seconds, in that 10 seconds, 3 seconds is actually taking in uh, your your uh, your browser side, 4 seconds is actually taking in app side, and another 3 seconds is actually taking in DB side, like that. So that is actually engineering. Engineering is something one layer about your performance testing, because performance testing only focus on numbers. Performance engineering is actually focused on the details about that problem. Details. Okay. So I know definitely in this forum, those who are already doing performance testing activity, your manager or your customer will expect you to do the performance engineering activity also. Okay, you can ask me the question, sir. Yes, sir. I received a request from my manager to start certain performance engineering activities also. What I have to do, sir? Where I have to start, and then what things I have to learn, like that. So that is what this course is all about. Okay, this course basically deal with that content only. What you have to start, what are all the things you have to learn, and then which is actually the benefit for your application team. Okay, so now you will get that understanding. Okay, performance testing is only testing the application. Performance engineering is goes beyond, and then you are going to say, okay, I found that the response time is this much, CPU is this much, memory is this much. I wanted to go into the details of that, and then try to help the developer or try to help the application team to fine tune or resolve the problem. Fine tune or resolve the problem. Okay, the person who is actually doing this activity, performance engineers. Okay, performance engineers. Because you can ask me the question, sir, the same activity done by the developer also, right? Why performance engineer is actually required? Actually saying, developers in most of the organization, they are busy. Don't think like I'm blaming developers. Developers are always busy. Okay, they are working for the release level activity or sprint level activity. They are working for integration testing activity. They are working for user acceptance testing activity. So a lot of work assigned to them, and they are completely occupied. They are completely occupied. Because of that, they cannot focus on these kind of line items. Okay, if you think, like you have to fine tune the performance, or you have to go through your script one more time, like that, if you are telling it to them, they'll say, no, I don't have sufficient time to. Jairaj, any question, Jairaj? So those who are not talking, please go on mute, please. Okay. So if you are asking them, they'll say we don't have time. Okay, and they are working for the release level activity also, right? So they will not do most of the time these activities. But performance engineers are dedicated person. Performance engineers are dedicated person. Their primary activity is to do optimize your application performance. Their primary goal is to optimize your application performance. So that is where the performance engineer's role is actually very, very important. Okay. Simply testing the application, providing the number, nowadays customers are not encouraging. They are expecting you to do more activity. Okay. Say I'll ask the question in this forum. Say we are doing a performance testing. Say like we all are working in a single team, in a single performance testing team. We did one application performance testing, and in that search transaction is actually taking 12 seconds. Search transaction is actually taking 12 seconds. And that search transaction 12 seconds report, we are sharing it to the stakeholder. Okay, customer or developer, to whomever, we are sharing that report with search transaction is actually taking 12 seconds. What reply they will give, guys? What reply they will give you if you are saying search transaction is actually taking 12 seconds? What they will say basically? Think from the stakeholder side.
They'll ask you like the ways of improvisation,
Okay. Yeah.
how you
First
can
one.
improve the performance.
Yeah. Yeah. Very good point. What else? Think from the stakeholder side.
Suppose they have set the SLA somewhere below 12, then they can ask that why they are taking 12 seconds, where it is breaching the SLA.
Okay. Yeah. Very good. What else? What else
Which
your
services
stakeholder?
are taking more time?
Yeah. Very good. What else? What else they'll ask? Okay. So very good. At least you guys are attempting for these things. So first of all, if you are sharing this kind of a number, okay, search transaction is actually taking 12 seconds. Means usually the stakeholder will get little upset. They'll say, "Boss, what is this, boss? You are saying only 12 seconds. I mean, you are only giving the detail as 12 seconds. Even using a stopwatch, I can find this particular transaction is actually taking 12 seconds. Why you took 1 month? Okay, you prepared, you collected the requirement gathering phase, and you prepared the scripting and did the execution. You prepared the report, and finally you are coming and saying search transaction is actually taking 12 seconds. This thing I can get it using simple stopwatch itself. So why you are saying after doing performance testing you are saying 12 seconds? Please give additional information. Don't give only blind or general data. Only whatever load testing tool is actually giving. Don't give that data alone. Why don't you give a detailed information? That is the ask from the stakeholder side, because stakeholder needs information. They don't want something I mean high level, or they don't want something general information. Okay, so in that case only performance engineering concept is actually comes into the picture. Okay, so performance engineering, now we got the understanding. Okay, testing means what, performance engineering means what. Performance testers, they'll only do testing, they'll move to the next release level activity. Performance engineers means they are going to work on the optimization part. They are going to work on the optimization part. Okay, where I can optimize things. Okay, so actually in a very reputed organization, because I work with multiple organizations, right? In a reputed organizations, what they will do, like uh, say like a set of people are there. In that some junior developers and some senior developers are there in the team. Okay, so whatever the code developed by the junior developers, right, that will be reviewed by the senior developer in the same day. Okay, whatever the code developed by the junior developer, that will be reviewed by the senior developer in the same day, and then they will deploy that code, and then they are going to check the performance. Means that performance will be very good, because the same day the code review happened. The same day the code review happened, and they are maintaining the standards. In certain organization they'll have a coding standard and all. They have a coding standard checklist and all they will have. So because of that, they are very strict in their performance level. Okay, but in certain other organization, what they are doing, they are not focusing on these checklists, these problem statement and all. They are not focusing on these checklist and problem statement and all. They are not focusing. Why? What they are doing? Okay. Say I saw in one of the organization. Okay, what they did. I mean, lot of developers are there in that application. Close to 100 developers are there for that application. 100. Okay, close to 100 developers are there for that application. So what problem, day in, day out, people will come in and then they'll go, they'll join the organization, somebody will leave the organization like that, because 100 developers, right? So most of the time people will join and then they go out. So what will happen? The new joiners in that organization, that application, okay, that application, the new joiners, they will not get proper KT from the senior person, because the senior persons are fully occupied. The senior person, they are not giving proper KT, knowledge transfer, to the junior person. So what they did, instead of getting the KT, or if you are asking the code logic, whether the senior will think bad about us or what, like that, they thought, and then they started writing the code logic like this. Okay, if the condition is meeting, my code will work, else my senior code will work. This is how they started writing the code. Okay, if the condition is meeting, my code will work, else my senior code will work. So this is an utter waste of time, right? Because if you are properly following the process, you are going to get a proper application performance. But if you are writing like this, it is actually unwantedly wasting time, right? So these are the things that are not happening nowadays. I mean, the code review, code walkthrough, senior person reviewing the junior person code, or sharing the best practices, all those things are actually missing. That is the reason the performance issues that are happening means. So that's where the role of performance engineer is actually comes into picture, and performance engineer will involve in this activity, and they'll try to find fault, and then they'll try to optimize things, and then the application performance will be improved. So this is how performance testers and performance engineers role is actually differentiated. Any question, guys, till now?
No, sir.
So now going forward, if somebody is asking, I mean, testing means what, engineering means what, like that, if somebody is asking, you can pretty much define that to them. Okay, actually saying in most of the organization, they started the name. I mean, they started giving that name itself. I mean, the role itself, performance engineers, straight away. They started giving the name, job role itself, performance engineers. In most of the organization, they started removing the they started removing the job role as performance testers, because you are no more expected to do only testing. Don't say I will only do testing. No, we do not want such kind of a person. We want a little more from you. You need to provide little more insight about the report, or you put your little more effort to find the problem where it is. Okay, don't say only I will do scripting, I will do execution, I will provide the report to the customer, and then I'll move to the next release activity. No, that is not actually expected nowadays. Okay, nowadays you are not only required to do testing, you need to provide little more insight. Okay, that's the reason if you go and see any job description in the market, you will see at least one performance testing tool in the JD, and also one APM tool in the JD. APM tool like Dynatrace, AppDynamics, that are available in the JD. Okay, so which means that what your performance engineering, your performance engineering activity, if you wanted to do some additional tool, you have to use it and then try to find the optimization logic, right? So that's the reason they are providing APM tool logic. Okay, either Dynatrace or AppDynamics they are adding in the JD. Okay, so which means that not only performance testing, we are going to provide little more insight about the testing data. Okay, little more insight about the testing data. Why? Because the developers, then only they can easily fix the issue. They can easily fix the issue. This can be happening in two ways, guys. Okay, a performance engineer who is having a code knowledge, they can also do the optimization, or the performance engineer, they do not have the code knowledge, they can share the recommendations to the developer, and the developer can fix the issue. Developer can fix the issue. Okay, because this question will always come in the mind of all performance testers. Sir, do I require to learn Java, .NET, Perl, Python, Angular? Like that, they are started asking. Actually saying, if you wanted to choose your career in that layer, I mean, you wanted to go in that layer, yes, you can learn it. Nobody is actually restricting you to do that. But if you feel like, no, I don't have the coding knowledge, but I have a good amount of performance testing knowledge, or good amount of infrastructure knowledge, or good amount of database knowledge, or good amount of client-side performance knowledge. So in that case, you don't really require to do a development skill. But end of the day, I mean, I'm not saying like you should not read it, but end of the day, you wanted to expand your knowledge. You wanted to extend your coverage to across the layer. Means yes, you can learn the dev skill also. Okay, it's up to your own interest, but without that also you can still contribute to the performance engineering activity. Okay, without the dev skill also, still you can contribute to the performance engineering activity. So our course content is basically going to cover each and everything only. Okay, so now we have that understanding of performance engineering. Introduction to performance engineering means what is performance engineering, we have the understanding, right? Any question still now? Then performance engineering life cycle. Performance engineering life cycle. Okay, so any activity that you do, you should follow a life cycle activity. Okay, I mean, you are doing any code development, so SDLC, software development life cycle. When you are doing any testing, STLC, software testing life cycle. When you are doing any performance testing, performance testing means your performance testing PTLC, performance testing PTLC. Okay, when you are doing performance engineering, that's where you are focusing on PELC, performance engineering lesson. Okay, performance engineering lesson. Okay, so now our focus area, because we are learning performance engineering concepts, right? So PELC we are going to learn, performance engineering life cycle we are going to. Okay, so what I am going to do, because we wanted to have a comparative understanding, right? Comparative understanding, what is actually happening, right? The comparative understanding. So what I am going to do here, I am going to do a SDLC versus PELC. SDLC means software development life cycle. In that, I am going to explain the PELC. Okay, PELC I am going to explain. So first one, when developer is actually doing requirement gathering, I told you, right? SDLC, and then PELC. So when the developer is actually doing requirement gathering, what performance engineers has to do, they should also analyze the requirement. Performance engineers should analyze the requirement, and they also think about the system sizing. They also think about the system sizing. System sizing means what? You are going to plan your size of your systems, what is actually optimal thing, how much of a load that is actually going to come, how you are going to handle that load with the current infrastructure. Like that, system sizing related things and all performance engineers can focus on. Okay, so what are all the things, I mean, in that cycle, in that layer, what are all the things performance engineers can focus on? First one, right number of resource to provide satisfactory performance. What is actually the right number of resource? Okay, You require to have a quad core machine or octa core machine or hexa core machine, or what is that RAM size you want, what is the hard disk you want, like that. The resource that is actually giving you a satisfactory performance for the end user. Okay, that part we are going to discuss in the requirement gathering side. And then growth rate. Okay, what is the growth rate? Today this much volume, tomorrow this much volume, next month this much volume, next year this much volume, like that. Growth rate also you are going to focus. Growth rate. Okay, what is your growth rate? Okay, from where to where you are going to grow, because that is very important. Okay, without having that plan, if you are still simply using the infrastructure, means one fine day you will get a problem. Always you keep an eye on your growth rate, because the growth rate is very important. Okay, because your business is growing means your end user they are going to increase. So in that case, you should focus on the growth rate as well. Okay, and then storage requirement. Storage requirement means what? How much of a data that you are going to store. So if you are a retail based customer, means a certain set of storage you are going to do. If you are a healthcare customer, means set of storage that you are going to do. If you are an insurance customer, means set of storage that you are going to do. So storage requirement. Say like I am going to store so and so data. So if I am storing in this way, my current storage will not be sufficient. Means what I have to do, when I have to upgrade my storage, when I have to do the backup process, archival process. So all those storage requirements you are going to think. And then end user response time. End user response time. Okay, SLA basically. Okay, service level agreement. End user response time you have to focus. End user response time. Okay, that also you should focus. Okay, completely for the end user to see the loading of the page, how much of a time we are giving, or what is the SLA that we are setting. That is what end user response. And then number of concurrent user. Okay, how many user we are expected to have it in the system in the start of the application, during the start of the application, or during the progress of the application, how much of the concurrent user that we are expecting. And then peak transactions. What are all the transactions that are used multiple times, or peak level that are used. Okay, so these are the few points you have to think about during the analysis stage. During the analysis, performance engineer, when they are focusing on the initial analysis phase, they have to think about all these points. Okay, not necessarily everything will be available, but you have to at least discuss about those points, because later part of the time you should not feel like why we did not discuss in the early part of the discussion itself. So that's the reason I'm saying. So when the requirement gathering phase, when developers are actually doing it, you can focus on analysis or system sizing phase. Okay, so one thing I wanted to tell you, the performance engineering, it may be a proactive phase or the reactive phase. Okay, proactive phase or the reactive phase. Right now this comparative life cycle is actually a proactive phase. Okay, reactive phase means sometimes problem happened and then the customer will give the task to the performance engineer. That is also you can encounter. You can see those kind of choices also. But right now what we are discussing is actually a proactive one. I mean, when the developer is doing certain activity, along with the developer you are trying to do the engineering activity, so that you are not going to waste any time and money. You are not going to waste any time and money. Why? You think like this, guys. Okay, during the development phase itself, you are optimizing thing means, so you are not wasting time, you are not wasting money. But you develop the code after 5 years or after 10 years, you are trying to do performance engineering. After 5 years or after 10 years, you are trying to do the performance engineering. Means that is actually time consuming. Money will also be, heavy investment is actually required. Okay, during that situation. I mean, after 5 years or after 10 years, when you are trying to do any kind of optimization, means money also, heavy investment is required, and time is also you are going to waste. Okay, so that's the reason mostly if you are doing a proactive one, proactive will solve the problem then and there, and you are not going to waste much of time. Okay, So when the developer is actually doing the requirement gathering phase, performance engineer will focus on analyzing that requirement, and they'll also think about the system size. They'll also think about the system size. Okay, that is the first one. Next one is when the developer is actually, going to the architectural understanding phase means, yes, performance engineers also will do the architectural review. Why we are doing the architectural review? Because the system should be simple enough to understand. The system should be simple enough to understand. It should be very simple. It should be very simple. Okay, everybody should understand the architecture. It should not be complex. Okay, you should not touch your nose around your head. Okay, that you should not do like that. Your architecture should be very simple. Okay, everybody should understand it. And you should choose a right algorithm and data structure. Whatever the algorithm that you are using, whatever the flow that you are using, it should be simple enough to easily understandable. And then you should first know the architectural limitation. Okay, you should first, because every architecture will not be completely perfect, right? There are one or two limitations will be there. Means that also you should already aware of it and you document it. Okay, later part of the time, nobody should come and say there is a problem like that, because you should tell them, boss, during the early time itself, we know that this is actually the drawback and we document it already. Because the later part of the time, nobody should come and say there is a problem. Why I am saying, you think like this, okay? You think like a simple example. When you are constructing a building, during the basement time itself, you should know how many floors that I'm going to construct on top of it. Okay, that is a logic, right? During the basement time itself, you should know how many floors that I'm going to construct on top of it, because that's how you will strengthen your basement. After constructing the building, you cannot think about building 5 more floors or 10 more floors on top of the building, because your basement will not be supported. Okay, so that is called as architecture. So architecture means what? During the start of the architectural review itself, you should think about the futuristic things. Future. Okay, after 3 years, I'm going to do this. After 5 years, I'm going to do this. I'm going to incorporate certain other application. I'm going to integrate with this tool, that tool. All the provision should be there in the early part of the design itself. Because once you are constructing the application, after that you cannot do a major change in the application logic, because the fundamental architecture will not support. The fundamental framework will not support. So the architectural review has to be done properly, so that you have to think the futuristic things also. You have to think about the futuristic thing. In future, whatever the changes that are going to happen, whether my current application is having the provision to change the architecture or what, like that you have to think about. Okay, so say that's what, say like the architectural side, whenever we are talking about, that time only the scale up scale out concept that are coming. Okay, say like your application is actually facing a problem. Okay, so somebody is reporting your application is actually having some kind of a performance issue. Okay, so say like what we will do, you think like this. Your machine is actually having some 4 GB RAM. 4 GB RAM you are having. So somebody is reporting that there is a problem. You cannot straight away go and touch your code first. Don't touch the code first. You try to handle through the infrastructure itself, right? So what I am doing, I am adding one more 4 GB RAM in my machine. One more 4 GB, that will become 8 GB. Okay, one more 4 GB RAM, and I'm getting some kind of an improvement. Okay, not fully, some kind of an improvement that I'm getting. So what I'm doing, I'm increasing the RAM to 16. I'm getting some more improvement as well. I'm increasing the RAM to 32. Okay, I'm getting little more improvement as well. Okay, after to a certain point, you cannot increase the RAM size, because your chipset will not support. Your chipset will not support, your motherboard will not support, right? So to an extent only you can upgrade your RAM, okay, increase your RAM, okay. So in that case you cannot increase your RAM size, but you wanted to improve your application performance, okay, you wanted to improve your application performance. But what we did, we increased our RAM size vertically. Vertically means 4 to 8, 8 to 16, 16 to 32, like that. Vertically we increased our RAM size. Okay, this concept is actually called a scale up. Scale up. We are scaling up. Okay, scale up. This is also called as vertical scaling. This concept is also called as vertical scaling. Okay, or vertically increasing the resource. Vertical scaling. Okay. But what do you feel like? No, I need to improve the resource, but this is a maximum configuration I'm able to increase. It means what you can do, you can create one more copy of the same configuration. One more copy of the same configuration. Same 32 GB machine you can create it and put these two things into load balancer. You create one more copy of the same configuration and put these two machines into load balancer, or even you can create one more copy of the additional machine and then put that into load balancer. So which means that this concept is actually called as what? Scale out. Scale out. You are creating the similar copy of the application and putting it outside using the load balancer. This is actually called a scale out, or you can think about, I mean, the other name is actually horizontal scaling. This is actually called as horizontal scaling. Okay, horizontal scaling. Okay, so which means that, so architecturally, if you are thinking, you should have the provision to increase the configuration. If not, you have to think about putting the similar kind of the machine one more time and then put that thing under the load balancer. So load balancer, so what is load balancer? Load balancer is nothing but it is dividing the total load into equal machines. Okay, say like you are getting too many traffic from the end user, you are getting too many traffic. Okay, that traffic is actually balanced between the available servers. That traffic is actually balanced between the available servers. Okay, you think like you are going to a movie theater and then you are standing in one line for single line for getting that ticket for the movie. Only one counter is there. So you are going to move very slowly because only one counter is there. But you wanted to divide the load. Okay, you wanted to divide the load means you are going to have multiple counters, right? So here also load balancing. You wanted to do the load balancing means the load balancing is a component which will divide the load across your machines. Okay, so in that case, what is actually happening? Your load is distributed. So because of that, what is happening? Your performance will be improved because you are not going to stand in the queue for longer period of time. Standing in the queue is actually your delayed response time. Standing in the queue is actually delayed response time. But your load balancer is actually helping you to divide the load. So that will improve the performance. That will improve the performance. Any question, guys? So architectural side, if you are thinking, this is the best example. Okay, scale up, scale out, horizontal scaling, vertical scaling. Okay, you should have the provision to do improve the configuration. If not, you can put one more machines and then you can do the scale out or horizontal scaling can be done. Scale out or horizontal scaling can be done. Okay, so which means that, so architecturally you should have a clarity because not always you can go and touch your code. Okay, touching the code is not the first solution, it's a final solution. Okay, so what are all the workarounds that you can do to improve your performance means, yes, this level, I mean infrastructural level configuration that you are trying to increase means that is the easiest way to improve your performance. So in that, scale up means what? Vertical scaling means what? and scale out means what, horizontal scaling means what, like that we are going to understand. We are going to understand. Okay, when the developer is actually doing the architectural review, performance engineer is also going to do architectural review, and they have to do this kind of an understanding. This kind of an understanding they should have it. They should have it. Okay, so actually the learners who joined today, okay, the learners who joined today to evaluate us, okay, for them, this is Kumar sir number 801995247. Okay, 801995247. I'm putting his number in the chat. You guys can take it. This is Kumar sir number. Okay, this is Kumar sir number. Okay, I'll also put his number in the chat also. This is Kumar sir number. Okay, so 801995247 is number. Those who wanted to discuss with Kumar for course content, course timing, commercial related, anything that you wanted to discuss, you can discuss with Kumar sir. Okay, 801995247. So as I mentioned yesterday, yes, we almost started our discussion. The basic understanding session started. So that's how we are going to proceed. Okay, so this is actually the understanding session. This performance engineering means what, performance testing means what are all the life cycle activity, and then the hands-on things will start. Okay, so the learners who joined today for evaluating us, please reach out to Kumar sir for any further information. And all these videos we are recording, and we will share the videos in the playlist URL, YouTube playlist URL. Those videos you are going to have it for lifetime access. That is your video, you are going to have it for lifetime access. Even after the completion of the session, any number of times you can watch it, and then you can get the benefit. Okay, you can get the benefit. Okay, so which means that the videos you are going to have it for lifetime access, and this is actually a weekday session, Monday to Friday weekday session we are going to have it. The time slot is this time slot only, 7:30 a.m. to 8:30 a.m. IST. 7:30 a.m. to 8:30 a.m. IST, correspondingly in other locations. Okay, so if you wanted to see the timing, it is here. Okay, 7:30 a.m. to 8:30 a.m. IST, corresponding times in US, UK, and other locations. I'll copy paste this course content in the chat. You guys can take it. Okay, this is what we are going to learn for this entire course learning. Okay, all the artifacts, documents, sample applications, softwares, everything we'll share through Google Drive. Okay, we will share through Google Drive. Okay, Google Drive, you can download it, you can set up that application along with me, or post the session, you can do the configuration. All things we are going to learn practically. That's how, I mean, industry level what they are doing, that the same understanding we are going to have it in real world projects. What they are doing, that understanding we are going to have it. Interview preparation, interview question preparation also we are going to have it. So which means that sorry. So we are going to have the learning across the layer. Okay, so those who wanted to enroll yourself, you can enroll. So from tomorrow we'll still continue the learning. I mean, we started with the performance engineering life cycle. The remaining part of the performance engineering life cycle is actually there, so we will discuss that tomorrow. So it's actually a weekday session, weekend holiday, Saturday Sunday holiday. Every day one hour we are going to take it, 7:30 to 8:30, and 25 hours we are going to learn it. This is actually duration of 25 hours we are going to learn this course content. Any question, guys? Anybody have any question?
This course is for how many days?
25 hours.
25 hours. Okay, 25 weekdays.
Yeah, correct.
Sir, I had a question. So you said that we can do the scale up and scale out during infrastructure level. So this all are the kind of recommendation we can give to the application team, right?
Correct.
So
Correct.
this can be from the starting when we in the requirement gathering phase, correct? We cannot see similar kind of, if we suppose during testing I find out that some kind of issue is there with the application scaling, then
Hmm.
also we can recommend
We
this
can,
thing, or it is.
we can actually we can do it. So now even you don't go to that level. You think like you are doing a Jmeter performance system.
Mhm.
Okay. So your machine is not sufficient to do your testing. What will you do?
Yes, I will scale up or scale down.
Yeah, everywhere this concept is there. Okay, it is not about the application level. It is about the work that you are doing. Also, scale up, scale out. You can do it. Okay, or
Mhm.
the same concept applies over the application level also. Your application is not currently capable enough to handle the load. Means they can boost it. They can increase it. Okay,
Okay.
because
Okay.
your expectation is to do with 1,000 user load or 2,000 user load, means accordingly your infrastructure should be, and based on that they have to increase the infrastructure. Okay.
Okay. And sometime during when we are in the initial gathering phase, the client has not a clear picture on the complete growth rate or the storage requirement. Then, in that scenario, what is the approach?
assumption
If client.
assumption they'll do assumption. Okay, they'll do assumption. So that's what I told you while I'm explaining. Also I told you, right, not always every
Mhm.
data will be available. At least you have to discuss about those things, because later part of
Mhm.
the time you should not think like why we did not discuss about these things, because customer will ask this. Customer, they'll say, I don't know all these things, you need to educate me why it is required, why you did not
Mhm.
discuss about these points before. That is a usual discussion point will come from the customer side. So at least you should discuss with them. You can go with a random number or assumption number, whether it is actually exactly matching or not. In the real world situation, you can correct it. Okay, but you should
Mhm.
have certain understanding about those points.
Okay.
So while we are explaining about the requirements gathering phase, there was a point called peak transaction.
Hmm.
Can you just explain about that? I missed that part.
See, peak transaction means, say, like, I mean, I don't know how many of you experienced this and all. Monday morning, doctors will get more appointments. Okay, because people will will suffer something during the Saturday and Sunday. They'll be heavily booking the appointment in the Monday morning, or Monday will be there. Similarly, your travel booking things are probably in the Fridays, because people think like Saturday Sunday will go out and Fridays will have a travel booking thing. So these are the small example I'm saying. So there are application Monday to Friday, if your application is used, but in that Monday to Friday, a particular day only you are getting a peak volume, peak transaction. Okay, that peak transaction you should know. Okay, and that peak transaction if you are doing, that is actually called as peak load testing. Nowadays everybody started doing, instead of a load testing, they started doing one more testing called peak load test. They don't want to focus on the normal load, they wanted to focus on the peak load. So that is the reason everybody focusing on peak load test. Okay, which day I'm getting a more volume, that volume I'm going to test it. That is actually called as peak load test. So the transactions that are happening in that day, those are called as peak transactions.
It's
Clear?
a similar kind of a sale day we are saying for a
Yeah,
retail.
yeah,
We testing.
yeah. Black
Yes. Yes.
Friday, Good Friday,
Good
sale day,
Friday. Yeah.
rebellion day.
Yeah.
Yeah,
Black Friday.
Okay, thanks.
yeah. So the learners who joined today for evaluating us, and thanks everyone for giving me this opportunity to share my knowledge and experience with you people. Yes, we are going to still continue the same for the throughout learning. I mean, lot of things we are going to discuss, lot of important things, technical things we are going to discuss. That's how the entire course content is actually designed. So you don't want to miss anything. You wanted to continuously learn things, means please enroll yourself to do the continuous learning from. I mean, tomorrow also we are going to continue the same thing. Already we started the life cycle activity, and we are going to still continue tomorrow to get a little more understanding of the performance engineering life cycle. So the learners who wanted to enroll yourself, please reach out to Kumar sir. 8019952427 is number. You can reach out to him and enroll yourself. And thank you for joining today and evaluating us. Thanks for joining, and have a nice day. Bye bye.
Thank you, sir. Bye.